Hi, my name is Sakari. I'm a cloud software architect from Intel. In this video, I will talk about Envoy and what Intel has done to optimize Envoy's route matching, filter selection, and access control. So let's start with the quick intro to Envoy. Envoy proxy is a modern, high-performance, small footprint edge and service proxy. Proxies such as Envoy does a lot of things, but one of the major functionality is an API gateway and an ingress proxy. In that setup, Envoy sits between the clients and services. The client sends HTTP requests to Envoy, which routes the request to the service. There can be hundreds or even thousands of services. So how can Envoy know to which service to send the request? The answer is routing. To make the routing decision, Envoy checks the request parameters such as destination port and IP address, the path, HTTP headers, and many other details. Based on the parameters, Envoy decides to which service the request should be sent to. The decision is a result of a routing or route matching. Route matching involves matching the input, the request parameters, to Envoy routes. Envoy is configured to have routes which contains the service endpoints where to send the data. Envoy uses regular expressions to do the route matching. We'll talk about the regular expressions in a second, but I want to define our problem statement first. Route matching can take a lot of Envoy CPU time if the routing table is large. How can we make sure the route matching is faster and less CPU intensive? So next, we'll talk about the regular expression and Hyperscan. A regular expression, regex in short, are used everywhere in the internet. They are used to search pattern in text. One typical use case is route matching, which also Envoy uses. The disadvantage of using regex is the computational complexity, which is not always known beforehand. Even if you can avoid the worst case, the runtime in most cases is linear to the size of the input set. Envoy uses an RA2 library to do the regex matching. You can see from the call graph on the left, which I'm not going to dive in, that there's a lot of calls with the high CPU utilization that are used to perform the regex matching. Back in March this year, a community member reported a high CPU utilization on Envoy when the route table was large. In this case, it was 4,000 routes. A few weeks later, Envoy accepted Intel's contribution to add regex matcher to the upstream code base. Hyperscan is a high-performance regex matching library. Hyperscan uses SIMD instructions to perform the simultaneous regex matching. SIMD stands for single instructions, multiple data. And it means that the CPU, such as Intel Xeon, can process multiple data sets with single instruction. The latest Intel Xeon scalable processor Ice Lake has SIMD version called AVX512. A typical processor can do 64 bits per clock cycle, but AVX512 can do 512 bits, an 8x increase. Hyperscan uses this multiple regex matcher at once, and that is the magic behind this performance increase, which we're going to show in a second. Then how can you use Envoy Hyperscan? All you need to do is to change the default configuration on the left-hand side to the Envoy with the Hyperscan configuration shown on the on the right. And that's all you need to do. And we'll take a look of the demo setup, how we're going to demonstrate the performance gain of the Hyperscan library. Next, we're going to talk about the demo setup. So the demo setup is the following. We have an Azure Kubernetes cluster with 3 nodes. All the nodes are Intel Xeon's Ice Lake instances, standard D4, DS, which has 4 CPUs. We use Fort.io benchmarking tool to generate and loop back the HTTP traffic. We use the Fort.io client to measure the latency and the QPS numbers. We have 2 pods for envoys, each having 4,000 routes. One envoy is configured to use the default RA2 library. The other one is configured to use the Hyperscan library. we first measure the Envoy with the RA2 and then Envoy with the Hyperscan. Also, the Envoy pods are configured so that they can only use a single CPU and 2 gigabits of memory. All right, let's do the demo. So here we have the Azure cluster. We have the files for the demo. This 4000 .yaml is the Envoy configuration file. As you can see, it's pretty large. We have the benchmarking demo, the script. We have the Envoy and the FortIO deployments, which we have deployed already on the Azure cluster. We have 2 pods, one Hyperscan and RA2. These are same Envoys, but with the different configuration. And we have the FortIO client and server pods. So now we're going to run the benchmark. We're going to only run 1 round, and the time is only 5 seconds. And as you can see here, first we run the RA2, the default one, and that will give us a P99 latency, 900 milliseconds, with the packet rate close to 2000 queries per second. Whereas the Hyperscan one, the P99 latency is much slower, and the packet rate, the queries per second, is larger, bigger. So this one kind of gives you a very quick overview how we can run the demo, and on the next slide we'll show the graphs for the a little bit longer run. In this performance comparison slides, we have the results from a longer runs between the RA2 and the Hyperscan libraries on Envoy using 4000 routes. So on the left-hand side, you see the latency number where the lower is better. And you can see that we get a 16% improvement with the Hyperscan. On the right-hand side, you have the queries per second, where the higher is better, and you can see that the Hyperscan gives us a 20% improvement. In summary, we can talk about what we have learned today. So if you use Hyperscan to accelerate your route matching, all you need to do is 3 things. You need an Ice Lake instance, either in a public or private cloud. You need an upstream Envoy binary or Docker image. For the IVX 512, we go with the note that you need to build your image yourself. For now, we are working on to fix that, but that's the case right now. And then finally, you need to change the default Envoy configuration, the routing, to use the Hyperscan library. You can do these in many places, including the public clouds, Google, Azure, AWS, and many more. Then finally, the future work we are continuing to work on is the Istio integration. So you'd be able to turn on the Hyperscan from Istio. And then a little bit longer term is to be able to use these Hyperscan APIs from a Maven plugin. That's all I had today. Thanks for listening.